All right, we're going to do a little bit more practice with graphing linear equations using a table of values. The first question says, determine whether each ordered pair is a solution for this equation. So we have x minus 4y equals 12. That's the equation we're going to use. We're going to determine whether each of these is a solution. So don't forget you're plugging them in as x and y together at the same time to see if it makes a true statement. So if I have the point 0, negative 3, and I plug it in for x and y, it's going to say 0 minus 4 times negative 3 equals 12. Is this a true statement? Well, we don't need the 0, and negative 4 times negative 3 is positive 12. So this is a true statement. So what does that mean? Yes, this is a solution because it made a true statement. When we go over to this next one, we're going to plug in negative 4 and positive 4, x and y. So negative 4 minus 4 times positive 4 equals 12. So that would be negative 4 minus, so this is negative 4 here times positive 4 is negative 16. Negative 4 minus 16 is actually negative 20. So these are not equal. So that means that this is not a solution because they're not equal. All right, we're going to complete the table of solutions for this equation, y equals negative x plus 5. We have x values. All we have to do is plug them in here, being careful that if the x value has a negative on it and there's a negative here, there's going to be two negatives together, and then add 5. So let's work over here off to the side. I'm going to actually rewrite this equation so I can see it. Y equals negative x plus 5. So that's the equation we're working with. We're going to plug in negative 2 for x. That would be y equals negative x, or negative 2 plus 5, which is positive 2 plus 5, which makes 7. So this is one ordered pair. And then we have y equals negative 1 plus 5, which is positive 1 plus 5, which makes 6. So this is another ordered pair. Then we have y equals negative 0, which there really is no such thing, so it's just 0, plus 5, which is 5. 0, 5. Next we have positive 1. So y equals negative 1 plus 5, which is 4. And then we have a positive 2. So y equals negative 2 plus 5. And the reason for this negatives, you guys, is because there was a negative in the original equation in front of that x. So this negative has to go on in front of every single number that you're inputting for x. So negative 2 plus 5 makes positive 3. So we have 2, 3. And one more. Y equals negative x, negative 3 plus 5 makes 2. So here's our ordered pairs, 3, 2. If we've done everything correctly, when we plot them on the graph, they will line up in a straight line. Got some issues here with the graph, it looks like. Oh, that's better. All right, so the first point is negative 2, 7. So negative 2, positive 7. It's going to be right here. Okay, the second point is negative 1, 6. So negative 1, positive 6, right here. And 0, 5 will be right there. 1, 4, 2, 3, and 3, 2. And they do indeed line up in a straight line. I'm sorry, I didn't quite hit the points, did I? So I'm going to erase this line and see if I can do better. That's better. Don't forget your arrows. You have to have the arrows. All right, so what's the next question? Complete the table of solutions for this new equation. 3x minus 2y equals 6, and we have some values for x and some values for y. So let's try it over here. If x equals 0, we'll plug that x in as 0 right there. So that'd be 3 times 0 minus 2y equals 6. 3 times 0 is 0, so negative 2y equals 6. So divide by negative 2, you get y equals negative 3. And we'll do it again with y equals 0 this time. So we're going to this one, which is y equals 0, so this time we'll plug the 0 in for y. So 3x minus 2 times 0 equals 6. And again, 2 times 0 is 0. So we just have 3x equals 6, so x equals 2. So we already have two ordered pairs. We have 0, negative 3, and we have 2, 0. All right, the next value we have is x equals 4. So this time we'll plug in 4 for x. So 3 times 4 minus 2y equals 6. 3 times 4 is 12. Whoops, not 12 there, 6 there. All right, we're going to have to subtract this 12 from both sides because we're trying to isolate this y. So when you subtract 12 over here, you're going to end up with negative 2y equals negative 6 when you subtract the 12 on that side. Divide both sides by negative 2, you get y equals 3. So this time we have y equals 3. So the third order pair is 4, 3. Okay, next we're going to substitute 9 for y. So we'll have 3x minus 2 times 9 equals 6. So 3x minus 18 equals 6. And again, you're going to have to add this 18 to both sides because we're trying to solve for x. When you add 18 to 6, you end up with 3x equals 24. So x equals 8. Divide by 3. So this is the next ordered pair, 8, 9. I'm running out of space to write. So the next one we're going to use is x equals negative 3. So 3 times negative 3 minus 2y equals 6. 3 times negative 3 is negative 9 minus 2y equals 6. So we're going to have to add this 9 to both sides. When you add 9 to 6, you end up with 15. So we have negative 2y equals 15. We divide by that negative 2. This just becomes negative 15 over 2. Y equals negative 15 over 2. Okay, one more. We have y equals negative 4. So I'm just going to scroll over here. and I'm going to put 3x minus 2y, which is negative 4, equals 6. So 3x, so this would be plus 8, because negative 2 times negative 4 is positive 8. So to solve for this x, we have to subtract 8. When you subtract 8 from this side, 6 minus 8, you end up with negative 2. So we have 3x equals negative 2. Divide by the 3. That just gives you x equals negative 2/3. So negative 2/3. So this ordered pair up here was negative 3, negative 15/2, and this one, negative 2/3, negative 4. Now, to graph these, I'm going to enlarge the graph a little bit here. All right. The first order pair is 0, negative 3, so that would be 0, negative 3 down here. The next one is 2, 0, so that's going to be over here. Next we have 4, 3, so over 4, up 3. They are lining up. It's always a good thing. 8, 9, so all the way over to 8, all the way up to 9 is way up here, but it does still line up with these others. It's way up here. Negative 3, negative 15/2. Okay, this is negative 7.5 when you change this to a mixed number. So negative 3, negative 7, 1, 2, 3, 4, 5, 6, 7.5, and that's going to be right down here. You can see it does line up with the others. So negative 3, negative 7.5. It's going to be like right there, in between the negative 7 and the negative 8. And this last one, negative 2/3, negative 4. Okay, well, this is negative 1, and 2/3 is less than 1, so negative 2/3 is someplace in this fraction space between 0 and negative 1. And then we go down to negative 4. So it's going to be like right here. It does line up with the others. It's right in there somewhere. You can't really be accurate with the fractions. You're just putting your points between two whole numbers. And you're going to try to draw a straight line between these points, not like that. All right, so let's try it again. There we go. And don't forget your arrows. Okay, we have a couple more equations. We're going to do the same thing for this graph using the table of values. This time I'm just going to fill in 3 values for each table. You really only need 3 unless you have a teacher that's asking you to complete the entire graph, or there's some directions that say use the entire table. You really only need 3. 3 points determine a line. 2 points determine a line, but the third point is to make sure you didn't make a mistake. So we're going to choose some values for x. I always use 0, 2, and negative 2, but you can use any values you want. Your line should still come out the same as mine. When I plug in 0 for x, let's see if we can do this mentally. 2 times 0 is 0. 0 minus 1 is negative 1. So y will equal negative 1. And that will be the first ordered pair. Okay, when you plug in 2 for x, 2 times 2 is 4. 4 minus 1 is 3. So y will equal 3. And that will be the second ordered pair. That's not negative. Okay. When x equals negative 2, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. If you need to write it down, feel free, write it down. Check your answers. Sometimes, depending on the form of the equation, when the equation is solved for y, this is sometimes easy to do mentally as long as there's no fractions involved, which is what I just did. Now we have our ordered pairs. We can graph them. So we have 0, -1. So that will be down here on the y-axis, 0, -1. We have the point 2, 3. So that would be 2 over and 3 up. Will be right there. And the point -2, -5. So -2, that's to the left, and -5 is down. And that will be down there. And it does line up with the others. So when they line up, you know you did it right. If you're trying to freehand these, there we go, that wasn't too bad. Don't forget your arrows. All right, we have a new one down here, and I don't think we're going to be able to do this one mentally because of the form of the equation. This equation is in standard form. But we're still going to choose values for x that we like. I'm going to put 3 values for x in over here, substitute them in. What are we going to use? 0, 2, and -2. And then we're going to go down here to the white space and find out what happens when we substitute 0 for x. So we'd have 5 times 0 minus 2y equals 10. So 5 times 0 is 0, so that term has a value of nothing, 0. So what we really have is -2y equals 10. When you divide by -2, you get y equals -5. So that's the first ordered pair. 0, -5. Okay? When we plug in 2 for x, we'll have 5 times 2 minus 2y equals 10. 5 times 2 is 10. And since we're solving for this y here, we have to subtract this 10 from both sides. Well, 10 minus 10 is 0. So we end up with -2y equals 0. We divide by -2, y still equals 0 because 0 divided by -2 is still 0. So this is the second ordered pair, 2, 0. All right, this time we're going to plug in -2 for x. So we're going to have 5 times -2 minus 2y equals 10. 5 times -2 is -10 minus 2y equals 10. All right, we're going to have to add this 10 on now because we're trying to solve for y. So when we add 10 to this side, it's going to become 20. So we're going to have -2y equals 20. 10 plus 10 is 20. Divide by -2. You get y equals 20 divided by -2 is -10. So our third ordered pair is -2, -10. So we're going to graph these on the graph. Let's enlarge it a little bit. So we have the first point is 0, -5. So that's 0 not going left or right. Then we're going down to -5. 1, 2, 3, 4, 5. That's right here. So 0, -5. Right there. The second point is 2, 0. So to the right 2. No vertical change. So right there on the x-axis. 2, 0. And the third point is -2, -10. So -2 this way. -10 is all the way down, and it is the end of your graph here is -10. So that would be right there. And it lines up with the others. Right there. Okay. And we're going to try to freehand this line. Maybe if I make it a little smaller. There we go. And don't forget the arrows.